Alright, let's do example 5-6. It's on page 45 if you want to follow along, but I'll write it down. You'll see a lot of these kind of problems. Alright, so it's 3i squared plus 2i to the fifth minus 3i plus 2i squared. And you just have to simplify that, and that's what this thing says to do. Oops. What did I say? Did I say squared? Yeah, cubed. Alright, so it says to simplify. So if we remember what the I cubed is. Do you remember? Now, if you can't remember off the top of your head, you could always do this. The one thing that you should remember is I squared. Alright, so I cubed is the same as I squared times I. What's I squared? It's negative 1. Alright, so it's negative 1 times I. So what's negative 1 times I? Just negative I. Okay, so anytime you see an I cubed, it's the same as negative I. So we're going to do this. We're just going to put a 3 in a parentheses and a negative I. Alright, let's do the next one. I to the fifth. So how do we figure out what I to the fifth is? I come over here off to the side. Now we can go a little bit bigger than I squared, right? What's one that's bigger that you have memorized? I to the fourth. So we're going to break this down into I to the fourth times I. Do you agree that's I to the fifth? Yeah, because that's I to the first technically. I just didn't write it there. So why do we care about I to the fourth? Why would I even write it as I to the fourth? Because what's I to the fourth? It's a 1. Good. It's a positive 1. So that just goes away, doesn't it? Technically, it's being multiplied by I, but we could think of it as just going away. All right, so I to the fifth is the same thing as I. So instead of 2i to the fifth, we could write it just as what? 2i. All right, it's the same exact thing. Minus 3i. Well, we can't really simplify that. It's already just an I, so we'll just keep it minus 3i. Let's look at this. Plus 2 times I squared. I squared is one of the ones you should have memorized. What's I squared? It's just negative 1. Good. You with me on that? So I just broke them down little bits at a time. Now you may be tempted to do a whole lot in your head and try to write down as much of the answer as possible, but I'm showing you every little possible step so you don't get confused. Alright, so let's take a look. 3 times negative I. What's a better way to write 3 than parentheses? Yeah, just negative 3i. So let's write it like that. So it's negative 3i. The plus 2i, we can't really do anything with that. We'll just keep it plus 2i. Minus 3i, you can't really do anything with that. Just keep it minus 3i. And then this is plus 2 times negative 1, which is just what? Minus 2. Now we have to simplify this thing, right? So let's add up the like terms. Look, this has I, this has I, this has I. So add them up. Negative 3i plus 2i is negative 1i. Negative 1 minus 3 is negative 4i. And then minus 2. Now that may look like, okay, that's fine, that's your answer. We didn't talk about this. I actually mentioned this word, and this whole section is under this phrase right here. We've just been talking about imaginary numbers. But when you have a combination of a real number and an imaginary number, a real number is just a regular number that we usually work with. When you have a combination of a real number and an imaginary number, we call that combination a complex number. So we'll backtrack just a second here. And we have a certain way that we write a complex number. Again, it's a combination between a real and an imaginary. This is what they do. They write A plus BI. The A represents the real number, and the B is with that I right there, and the I, of course, is what kind of a number? Imaginary. Okay, so that's the imaginary number. Alright, so this is the real number, and this is the imaginary number. So what goes first? This is the form that you want to write a complex number in. What goes first? No. Well, yeah, as far as here, just let's stick with this first. The A, the what? The real. The real always goes first, imaginary always goes second. Alright, Judah, now we're not going to write it like this as an answer, because to be a real complex number, what would go first? Go ahead, Judah. The negative 2, right? So it's going to be negative 2, what? Minus 4i. This is the correct way to write it, not this way right here. Alright, so you write the real number first and then the imaginary number. I took a class in college and it was called complex analysis. And the complex was because we basically did calculus with complex numbers. Right? It was basically a first year calc course, but we used all complex numbers. And that's where we learned the imaginary numbers and all that kind of stuff. All right? And it was very, very important in that class to make sure that you had your real numbers first and the imaginary numbers second. Right? I can't remember specifically, but if I remember right, um, if you wrote your answer like this, he probably would mark it wrong, right? Because it's not in the correct form. This is the complex number form, a plus bi. So the real number must be first, the imaginary number must be second, right? So this whole thing, it looks like two different numbers, but technically it's one complex number, right? Now, there are reasons that people use this stuff. I can't sit here and give you specific reasons because it goes beyond my basic knowledge, right? But I talked to a kid that I taught. I think I only taught him 1 year of geometry or something, but he grew up at Newcastle, and I'm still friends with him today. Um, and you ever see the picture on the slideshow of the aerial shot of the school? There's been a few floating around. It's on the website and that kind of thing. He's actually the guy that takes me up in the plane. He's a pilot. He takes me up and rides or flies me around the school, and I take pictures of the school and stuff every once in a while. So anyway, it's the same kid. And one time, he's now a engineer at Boeing, right up there on the way to Philadelphia. And he works with, I know the last time I talked to him, he worked with helicopters, like fighter helicopters. And this was years ago, but he worked with the, what do you call it, not the dashboard, but the control panels in the helicopters, and they were converting from analog systems to digital systems, and he was on a team that helped do that kind of stuff. It sounded pretty cool, and they even got to give him rides up in the helicopters, in these fighter helicopters, which is kind of cool. But he came in one time, this was a few years back at my other school, and I said, Danny, come in and show us some reasons why we learn imaginary numbers. He says, I'll be glad to do that. He came in, and he went way over my head. I had no idea half the stuff he was talking about, but it was pretty interesting. With electrical engineering, and he's an engineer, with electrical engineering, they use imaginary numbers and complex numbers all the time. And he was giving me all these examples, how you can use it and why it's used and blah, blah, blah. And I had no idea what he was talking about, but I'd nod my head to make me sound like I was smart. Here was a kid that I knew since he was just a little guy, and now he was telling me all this stuff. But it can be used, and I can't sit here and tell you exactly how, but if you continue on and you become an engineer, electrical engineer, maybe they'll teach you that, and you can come back and tell my class how to use it. All right, so anyway, this stuff can actually be used. Don't really know how right now, but it can. Just believe me on that. All right, let's do another example with complex numbers, and we'll switch gears, get to something else. Let's backtrack just a little bit because we're going to use this in this problem. Remember what I said the square root of -1 was? It was just a basic definition. What was it? It was just I, right? Okay, we use the letter I to represent the square root of -1. So what if I had this? What if I had the square root of -2? How would I rewrite that? Well, I could do this, couldn't I? I could say it's the square root of 2 times the square root of -1. Would you agree with that? You wouldn't agree with that? Yeah, actually, let's slide a middle step in there if you don't agree with that. Watch. Oops. Ooh, my goodness. Let's do this. Let's go negative. Oh, I don't want the -2. I wanted 2 times -1. Would you agree that the square root of -2 is the same thing as the square root of 2 times -1? Yeah. Well, we have a rule in algebra that says when I have two things multiplied together and it's in a square root, I can split them up into two individual square roots. I have a rule that says that in algebra. I'm not going to show it to you. You just have to believe me. You should have learned that last year already. So watch. If I split them up, the square root of 2 is right here. The square root of -1 is right here. Now do you believe me? All right, you should. If you don't, look it up in your Algebra 2 book, okay? So watch. What I did is I got that square root of -1 off there by itself. So how could I rewrite this? It's just the square root of 2, what? I. That's right. See it? Because the square root of -1 is an I. So I took the square root of -2 and made it the square root of 2i. Let's just do this. What's the square root of negative 7 then? How can I simplify the square root of 7? What would that be? Yeah, that's it. Square root of 7i. Basically, you take that negative out of the square root, you just turn it into an I. Do you see that? So you take the negative that's inside the square root, you take it out, you make it into an I. What if I had this? What if I had the square root of negative 9? What's that going to be? Okay, simplify it further. Is it the square root of 3? Is that what you want to say? It's just 3, right. It's just 3i. Alright, because you said the square root of 9, right? So the square root of 9 is what? 3. It's not the square root of 3, it's just the number 3. So the square root of 9 is 3. That negative that's inside the square root turned into an I. You with me? Now, let's go back to this and see if we can solve this. Let's rewrite the square root of negative 3. How would I write that? Square root of 3, I. What's the square root of 4 going to be? Come on. It's just a 2. Square root of 4 is just plain old 2. Alright? You guys are thinking way too hard. Okay. Plus, let's do this. Let's write down the 3. I'm doing every little step by itself. I'm not trying to combine anything together. Alright? I'm just doing little parts. So I can put down the 3. What about the square root of negative 2? That would be not 2i. Right, the square root of 2, because I can't simplify the square root of 2. Right? So it's just the square root of 2, what? I. What's the square root of negative 9? Right, it's 3i. It's not the square root of 3, it's just 3i. Those are all being multiplied together, correct? Let's do this. Put a plus. Let's do this. The square root of negative 16. What's that? It's just 4i. Good. And then this is just square root of regular positive 16. What's that going to be? Just a 4. Good. Now let's simplify stuff. Do you see how these are all broken up with pluses in between? Let's do each term individually. So let's just do this and this. Can I really do anything? Is this a square root of 6? No, because that's not a square root right here. So the only way I can write that is 2 square root of 3, what? I. Now sometimes they put the I out front. Right? Remember, the I is not under the square root, is it? It came out by itself. So sometimes they put it out front. I don't know. I kind of like it over off to the right like this. Let's do this. Let's simplify this thing right here. Well, I got 3 times 3, which is 9. And then I got a square root of 2. But then I have an I times an I. What's I times I? It's I squared. What's I squared? It's negative 1, isn't it? Now look, eventually what I'm going to do is just turn that plus into a minus, but I'm just going to show you the steps so you can see where we're getting that stuff. Alright? Now look, plus 4i, can't do anything with that. Plus 4, can't do anything with that. Now let's see what I can do. Well, let's just clean this up a little bit. Instead of this times a negative 1, that just makes it, watch this, 2 square root of 3i. Instead of plus this, what am I going to write? Just minus, right, 9 square root of 2. You might have been able to do that step a little earlier instead of making this an entire step, but I just want to again show you how to write this. Now look, this has an I and this has an I. Remember yesterday I said the book, it factored out that common term? Do you remember that yesterday? Okay, you can look it up. But look, this has an I and this has an I. So let's put the real numbers together and let's put the imaginary numbers together. And again, it doesn't matter. I like to probably rather put the whole number or the positive number first. So I'm just taking the real numbers right here, the ones without the i's. So take 4 minus 9 square root of 2, and then take the i's and put them together. Let's put the plus 4i first, okay, and then the plus 2 square root of 3i next. Now what they do is this. Instead of having an I here and an I here, you can't really mess with this. You can't do anything with that, but watch what you could do here. You could put plus, and then you have an I. If you factor out an I, what do you get? 4 plus 2 square root of 3. If you wanted to put that I on the outside, that's perfectly fine. So if you want to clean it up, this is the way the book writes it. It's 4 minus 9 square root of 3 plus, and then parentheses, 4 plus 2 square root of 3, parentheses, and then an I out in front. Okay? That's how they write the answer right there. Alright, took us right up to the time.